Welcome again to Math Essential Coordinate Systems. Today we are going to have discussion on 2D coordinate systems. So the purpose of this video is to introduce Cartesian and polar coordinate system and understand what is unit vectors in both cases. As we have discussed in the previous video, if we want to build a two-dimensional coordinate system, we need two axes, and also we need a reference point, which normally it will be named origin, and it is an intersection between the two axes. So there is two main coordinate system which we explained. The first is the Cartesian, and in this case it will take x and y coordinate system, which are of course perpendicular to each other, to describe a point P in the space. So if you moved in x direction as a distance x, and in y direction distance y, you can say our point is P of x and y. And another thing we need to define is the distance between the origin and this point, which we will name D. And actually the vector D, now we have vectors, we call it displacement vector. What it will be, it is the value of x multiplied by something called unit vector I, plus y multiplied by unit vector j. Y, I, and j, either I and j, or sometime in some reference you say ax, but you have this hat representing a unit vector, and ay. So this is another description how you define the unit vector. Simply unit vector, it means that it has a unity distance. So if we want to calculate the distance now between the origin and dxy, we are in a right angle triangle which have x and y and d as a hypotenuse. And by applying the Pythagoras theorem, we obtain that our d, this one of course is just the distance, not the unit vector, equal to the root of x squared plus y squared. So now we define what's called infinitesimal length and infinitesimal area, which are used normally in integration and differentiation. So in the Cartesian coordinate, simply you want to move a very small distance delta L in some direction. Normally this delta L, if you represent as a vector, will equal to delta x in the I direction plus delta y in the j direction. Now if you apply again the Pythagoras theorem, you can get that delta L as a distance will equal to the root of delta x squared plus delta y squared. Similarly, delta A, if you have very small area here in delta x and delta y, so this area delta A will be simply multiplication of delta x and delta y. Now we move to the second system of coordinates, the polar coordinate system. And in the polar coordinate system, instead of x and y, we will have a rho and phi. Rho is a distance, and phi is the angle from the reference axis, say x in this case. So the position of a specific point P will be defined as P of rho and phi. In this case, the displacement vector connecting the origin and the point P will be equal to rho multiplied by the unit vector rho, and again unit vector rho is the vector that points outward from the origin. So if you here unity, you have rho, and the unit vector phi, you are rotating in a circle, So the tangent to this circle will be the unit vector phi. And as we will learn soon in this video, this row actually is just x in I direction plus y in j direction, of course divided by the root of x square plus y square, such that it it is a unity vector. And if you substitute by this in the d equation, you will have this one is equal to xi plus y j divided by this root again, y square, multiplied by rho. And actually rho is just equal to x square plus y square under the root. So you will return to what we have explained in the Cartesian coordinate. It's just equal to x in the I direction plus y in the j direction. So now again, in order to smoothly do integration and differentiation, we need to understand what is the infinitesimal length and infinitesimal area. And for rho still is a distance. So we can simply say delta rho is just very small distance, right? But what about delta phi? Can we just use it? Actually, no, because phi is just angle. It is not a distance. So what actually phi is defined as? Phi is defined as the arc length, say LA, divided by what? Divided by the radius. And if we say what is delta phi is equal to delta LA divided by the radius rho. And in reality, what will change in length is delta LA. So we can rewrite delta LA equal to rho d phi. So in case of phi, what it change in reality is the arc length, which is delta LA, which is in reality equal to rho d phi. So this is what we are calculating, this area, for example. And this one small arc length here is delta LA. Now we can say that our displacement, infinitesimal displacement, delta L, is equal to delta rho in the rho direction plus rho delta phi in the phi direction. And since this vector analysis, simply we can say that if we want to calculate the in terms of distance, delta L, then we take the root, and this is unit vector, so we make square of this quantity and square of this quantity, which is multiplied by the unit vectors. Similarly, if I would like to calculate the area, I'll just multiply the area and the rho, sorry, delta rho, multiplied, this originally was delta rho multiplied by delta LA, and then we can just reformulate, because we already know what is delta LA from here. So we substitute and reformulate, then you will get rho d phi. So in this video, we have discussed the Cartesian and polar coordinate systems, and actually depending when we use it, actually depend on the problem symmetry. We will give in some problem in physics or engineering, and based on how the problem look, we can decide whether to use polar or Cartesian. And also what we have learned that there is a concept of unit vectors. And in case of Cartesian, I and j describe x and y direction, which are actually just directions. But in case of polar coordinate, we have rho and phi. Rho is also a direction, but and phi is the angle. But both of them will depend on, I mean, their direction will depend on where actually angle phi points. Thank you.